What's up, everyone? This is LeetCode 36, valid Sudoku. So we have to determine if a 9x9 Sudoku board is valid. Um, Also, I'm going to note, just to point this out, it's asking, we have to find out if the board is valid, right? Notice the problem is called valid Sudoku, not solve Sudoku, right? So make sure you understand that this problem is less complicated than you might think, actually. So only the filled cells need to be validated, right? So basically, we have the Sudoku board, we have filled cells, and we basically need to check if these filled cells follow the rules of Sudoku, which they lay out here, right? So each row, we can't have any repetitions for the numbers 1 through 9. Each column, we can't have repetitions in 1 through 9. And then each 3x3 sub box, right? So this is a sub box, this is a sub box, right? So there's 9 sub boxes, as you can see. In those 3x3 sub boxes, there can't be any repetitions of 1 through 9. Okay. So, if it is valid, we return true. If it's not valid, we return false. Okay. Now, for our approach to this, first of all, we are going to point this out, right? This box is, or this grid is 9x9, right? This board. Right? You see that in the constraints. Okay, so that's actually good for us. Makes the problem a little bit less complicated because our input won't grow. It'll always be fixed. The board length will always be fixed, right? 9x9. Now, how do we know if there's repetitions going this way, that way, and as well as if there's any repetitions in the grids, right? What we're going to do is we're going to have a hash map to solve this, okay? So we're going to say the maps will use the set as the values since the values cannot repeat. What does this mean? Is that for every row, we're basically going to create a hash map, and the key will be basically the indexes of the rows. It could be 0, 1 through, right, all the way up to 8. And basically this, for example, would give you the 0th row. Right, and as we traverse through the entire board, we'll basically check at each given row, and we'll do that by by the key, right? That lets us know what row we're on. If there's a certain value that already exists in the row, we're going to return false because we're seeing it a second time in the row or in the column, right? Because we're also going to use this set for columns as well, right? Like the 0th column. I don't know if that makes sense to you, but basically, right? Like for example, this is just really pseudocode-ish, but right, like when we're traversing left to right, for each row. So in the first row, right, we're adding a 5, a 3, a 7, right? Now let's say in the look at where my mouse is. Let's say in this cell there was a 3. Well, we would go to the 0th row and we see that there's already a 3. So when we add a 3, we say, hey, there's already a 3 there. We're actually not even going to add this, right? Because we'd fail our check because it already exists. So we would return false because it's not a valid Sudoku board, right? When we go to the first row, for example, instead of the 0th row, I'm using indexes here, right? When we go to the first row, we wouldn't use these values because again, the key would be row 1 because we're on a different row, right? And we would go 6, 1, 9, 5, right? And we would do the same process for the columns, right? We'd basically have another hash map where the key is just the actual column we're on. And that's also why the solution is really elegant, is because this grid is 9x9, right? So we won't have any weird edge cases. So it kind of makes this problem a little bit simpler than you might think. Now for the grid, the way we're going to do the grid is that we're going to, because of how truncating works in terms of integer division, where it rounds towards 0, we're basically going to take, we're going to take whatever row we're on, the index. For example, if we're at this 0, 1, 2, right? 2 divided by 3, right? That'll give us 0. When we go to the third, so basically, think of it like this. These subgrids right here, they're technically the 0th index, these are the first index, and these are the second index. And the way we, and the reason we're doing that is because we can pick a particular grid. So for example, when we go to this grid here, right? Let's say we're on some line here. This would be 0, 1, 2, 3. Like, let's say this particular cell. 3. So we do 3, and we're always dividing by 3, right? Because there are three boxes max in each direction. So we're always dividing by 3. Remember, we're doing integer division, so we need to do this. So if we're at this particular box here, or cell, where my mouse is, it would be 0, 1, 2, 3. So it would be 3 divided by 3, which gives us 1, right? So we know that we're at the first index for the sub boxes, so it's one of these boxes here, this one, or this one. Now, how do we know which one we're at? We're going to look at the column, right? So when we're at this one, this is what, column 8, right? 8 divided by 3 would give us 2, right? And again, this is just because of how truncating works with integer division, right? In Python, in any language, really. I shouldn't say in any language because I'm not sure if that's true, but you might implement it slightly different in other languages, but the point is we're doing integer division, right? And so it gets truncated off because we're really rounding towards 0. So we get 1 for the row and 2 for the column. So we know that we're at 1 for the row, so this is 0, 1. Okay, so we're at the first row for the sub boxes or the subgrids, whatever you want to call them. And we're at the second index for the column, so 0, 1, 2. So we know we're in here. So the way this is going to work is we're basically going to keep a hash map for each of these grids, and we're adding values towards that grid. So for example, for this particular example, right, for this 3, right, we would basically have a hash map where the key is this, right? Okay, the key is this. And what does this do? It basically points to this particular subgrid here, and then we add the value 3, right? And so we're saying, hey, we just added a 3 in the sub box. So if at some point, like let's say we have a 3 here, we would know that, hey, when we check the subgrid here, we already added a 3 to the hash map. So if we see another 3 like anywhere in here, we would have an error, right? So that's kind of how it works. It's really not too complicated. It's a little funky and weird, but that's basically how we check these sub boxes, is we're doing the division by 3, integer division, okay? Code is really simple too, so it'll make more sense when you see our code. But really, again, the way our solution's gonna work here is this, okay? So we have a map for the rows, and that's basically going to, technically I think the key should be on the left side here, but I'll just use the colon basically. The row is gonna map to a set of values, right? A set of values. And the column will also map to a set of values. Because the values in these hash maps will be a set. Because a set is a good way to basically check if each value is unique, right? Because if we can't add a 3 if there's already a 3 in the set, right? So yeah, I mean, it's just a simple way to implement this. And then so basically have 3 hash maps, right? And then this one is basically we get the grid doing this, right? And they map to a set of values. Okay, basically right, we're basically checking what values are in each subgrid. That's all we're doing. Okay, now we're going to implement this in, oops, let me do this. Now we're going to implement this in Python. For the Python, or for the C++ video, I'll cut right here, and we'll implement this actually in C++ for that video. Okay, we're here in C++. So we're going to create these hash maps. So we're going to make the one for the rows. Sorry, I blanked out there for a second. Right? So we're going to do char row map. Okay. Now, the key is going to be the actual index of the row we're on. So it's an int. The value is going to be basically a set of values we've already seen, right? You can use integers if you want. The reason I'm using char is just because the input is characters, right? They're not actually integers. They need to do that because they represent empty cells as a period, right? So yeah, I mean, implement it how you want, honestly, but we're going to go like this because it makes more sense, okay? So we're going to say unordered map int, the columns is going to be the same deal, right? I'm going to say call map. Okay. Now, the subgrid is going to be much the same, but it's slightly different, right? We're going to call it subgrid map. So, I don't remember if I explained this. I don't think I explained it before when I was making my Python video before I edited this. So we'll just explain it again just in case. But basically, to get these subgrids, when we're at a particular cell, to get the subgrid we're on, we're doing a division by 3, right? And the reason it's a pair is because this pair as a key here represents the coordinate of the subgrid. Because you see how there's 9 subgrids, right? You have a 0, a 1, and a 2 for the rows, a 0, a 1, and a 2 for the columns. So, for example, this here is 0, 0. This here is 2, 2, right? This box here. And so we basically store these points to get whatever subgrid we're on, right? And then that's the key, the subgrid. And then the value is the values that we add along. So for example, if we add an 8 to 1, 0, we're basically saying, hey, we have an 8 in this sub box. So if we encounter an 8 again for the same key, it means we have another 8 in the same sub box at some point later. And that's would be problematic, right? Because we cannot have repetitions in the 3 by 3 sub boxes. That is a rule that we're given in the problem statement, right? So, right, just keep that in mind. So here we're going to do 2 for loops to iterate through the board, you know, and this problem really isn't too difficult because it's the board size is fixed. I mean, if you go down to the constraints, right, it's 9 by 9, always. That makes this problem much more simpler. I mean, this problem could get far more complicated for sure. So we're going to say C by 9, C++, that's funny, C++. And we're going to say if board RC is a dot, right? We just continue because, well, we don't really care about dots because dots just represent empty cells. I'll just comment this just so in case you don't like writing your brackets like this and it confuses you. Order for loop. I'll just make sure I comment my code. Okay, there you go. Okay, in this else statement, what do we need to do? Well, we need to check these conditions if they've been violated because we're at a new cell, right? So we need to check if these, because we're not in the if statement, so we're not on an empty cell. We're at a cell that has a number. So we need to check if this number violates any of these constraints here or any of these rules, because then the board would not be valid, right? Sudoku board would not be valid at that point if any of these rules are violated of the game. So we're going to say if row map, right? And we're going to get the current row we're on, the current row index, and we're basically going to count the value, right? Because if that exists already, it means we've seen it in the current row. And we're going to do the same for the column, right? We're going to get the current column we're on. Now we're going to count, because if it already exists, hey, we have a problem because we've already seen this value in the same column. As well as we're going to check the subgrid, okay? So we're going to say subgrid map. And remember, the key for the subgrid map, the hash map, the key is a pair of values, and the pair of values lets you know what subgrid we're on. So when we're at this 3, right, this would be 0, 1, 2, 3. 3 divided by 3 is 1. So we know that we're on one of these rows, or we're on one of these sub boxes because this is the first index. And this 3 is index 8, right? 8 divided by 3, when you do the truncation, it's 2, right? So we know we're on the second index for the column, so 0, 1, 2. So when we get 1, 2 as the pair, we know that we're pointing to this particular subgrid, our subgrid box here. So if we already have a 3, when the key is pointing here, meaning we're pointing at this subgrid here, where my mouse is, if the 3 already exists, we have a problem because we're encountering it for the second time, and we would violate this rule, which says each of the 9 3x3 sub boxes of the grid must contain the digits 1 through 9 without repetition. Okay. So now technically it's not going to have 1 through 9, right? Like these empty cells are kind of irrelevant because we're not solving the board, we're just validating that it's valid, right? But that's besides the point, right? Just pointing that out. So how are we going to check this? We're going to say r divided by 3, right? We don't have to do anything special. It's just the way Python works. You have to do this, right? Because Python is just very weird. Because you don't have ints and stuff. Everything's just kind of done for you. Everything's an object. But in C++, it's just simple, right? R divided by 3, C divided by 3, and that gets us the particular sub grid box that we want. And we need to count that, right? Make sure that we're not seeing that for a second time. That we're not seeing the value that we're on for a second time for that particular subgrid. So we're going to do count board RC. Okay. Now, if we're seeing any of these for the second time, right? We're seeing a value for the second time in the same row, in the same grid, or a second time in the same subgrid, we have a problem, and we have to return false, right? Whoops. We have to return false, right? Okay. Now, if we do not return false, what do we have to do? We need to add those to the hash maps, right? Because this is the first time we're encountering it in the row, the column, and the subgrid. So we need to add those to the actual hash maps. Okay, so we're going to say row map r insert board RC. Okay. Whoops. Now we need to add it to the column hash map. For the key is the current column we're on. We're going to do insert board RC. Not too bad. And for the subgrid, right, we're going to do subgrid map. And we're going to do r divided by 3, c divided by 3 to get the current subgrid that we're on. And in that subgrid, we want to add the value. So we're going to say insert board RC, and that should be it. And then if we never return false, it means we can exit the nested for loops. That means we never ran into any issues, so this is a valid Sudoku board and we just return true. So yeah, problem isn't too crazy as far as difficulty goes. It's just a little weird. But yeah, the reason this works though, like you gotta just really keep in mind, the reason you can do this with so many sets and stuff for the hash map is because it's just 9 by 9. Remember that, right? This board is always 9 by 9. So this constraint makes the problem easier for us, right? So when I first did this problem, I was like, wait, you have sets for each of the 9 rows, each of the 9 columns, and each of the 9 subgrids here. It just seems so weird to have 27 sets. But I mean, it works because again, like we're never going to have more than that because of the constraints of this problem, right? So just keep that in mind. That's why this solution works just fine, even though it might seem funky. Like for example, when I first did this problem, I wouldn't have thought that using 27 sets is the optimal solution. Technically, there's a more optimal solution with using bit masks and stuff, but we're not going to do that. You can look into that for yourself if you want, but I think this is sufficient. Anyways, I hope this helped, and I'll see you in the next one. Peace out.